video about carnival games. Okay, we are now going to extend our talk about statistics into the realm of probability and chance. Okay, so if you're trying to make a fortune at a casino, this is your part of the unit. Okay, so the probability is the chance or likelihood of an event occurring. Probability is calculated as a ratio of the number of favorable outcomes to the number of total outcomes, where all outcomes are equally likely. Okay, and we are going to write our probabilities as a number between 0 and 1. 1 being that it's certain to happen. Okay, just because maybe it's been a while since we've talked about it, there are a bunch of ways to write a ratio. I can write the ratio 1/2 as 1 to 2. I can write it as 1/2. I can write it as 0.5, and I can write it as 50%. Do you guys realize that all of those things are the same thing? Yeah. Okay, perfect. Okay, for example, the probability of drawing a heart from a standard deck of cards is. Do you guys know how many? Do you guys know how many cards are in a deck? It's 52. And how many suits are there? 4. And how many are in each suit? How many cards in each suit? 13. So there are 13 hearts. Okay, out of 52 total outcomes, total cards. And then we have to write that as, we're going to write it between 0 and 1. So we're going to do a decimal. So that would be 1/4 or 0.25, correct?
Yes.
Okay. As a percentage, that would be 25%. Okay, so the next thing we're going to talk about is chance or likelihood. You can see the words chance and likelihood. Can we stop making weird noises? Okay, we can see the words chance or likelihood in the probability section, right? So sometimes chance or likelihood just means probability. Okay, it means the same thing as what we did up there. However, sometimes the word chance is used to refer to the odds of an event and not the probability. So the next thing, obviously, that we're going to talk about is odds, so you know what that means. Okay, odds are a ratio of the number of ways an event can occur to the number of ways an event can't occur. So probability is desired outcomes out of total outcomes. Odds are desired outcomes compared to undesired outcomes. Does that make sense to everybody? Okay, so here we had the probability of drawing a heart. Now we're going to do the odds of drawing a heart. So we still have 13 hearts out of 52 cards, right? But we're not going to use the total outcomes. We're going to do the not hearts. So it's going to be 13 hearts compared to how many not hearts out of 52? How many are not hearts? 39? 39 not hearts. So if I reduce that, what would that be? They have a common factor of 13, right? So that would be 1, 2, 3. And we typically write it as a ratio, like this, with a colon. So we're talking about the same thing, but this is out of desired total outcomes, and this is compared to undesired outcomes. Everybody okay with that? Okay. All right. Yeah, they're doing pretty good. All right, let's talk about trials. A trial refers to a procedure that can be repeated. And it's usually reserved for an experimentation or simulation where the experimenter adjusts a factor in anticipation of some result. So you guys know in like clinical trials and stuff, they'll have like a control where they have like a placebo, and then they'll have a variable that they change, which is like they have their medicine that they want to test. So compared to like the people who don't get medicine, like the factor that they adjust is like we give some people medicine, right? And then they see if it's effective. Okay, and then they have to make sure that it's repeatable so that other people can repeat the same experiment. It's not a good experiment if it can't be replicated. That's bad science. Any questions? Okay. Next, outcome. The result. Can you stop clicking? Thank you. The result of any trial is an outcome. Okay, so when I flip a coin, the trial is like the process, right? It's actually flipping the coin. Okay, that can be repeated. What is the outcome? There are two. Heads or tails. Okay, an event is a collection of outcomes. Let's say that we are flipping a coin twice. Okay, our possible outcomes are getting heads, getting heads and then tails, getting tails and then heads, and getting tails and then tails again. Okay, wait a minute. I just messed that up. Okay, they didn't write it like that. Sorry, guys. Oh, we're so sad. Okay, let's say that. Okay, they wrote it differently. Let's say that we want to. The event could be just flipping heads twice. I wrote out the sample space. Sorry, guys. That is a possible outcome. Okay, so flipping heads once is an outcome. Flipping heads twice is an outcome. Flipping them twice together, that is the event. Okay, it's a set of outcomes. Does that make sense? Okay. I listed all of the events instead of just one event is what we did wrong. I did wrong. Sorry, guys. Okay, a sample space is the set of all possible outcomes. Okay, the sample space for rolling a standard number cube, which is just a dice. Okay, what are all the possible outcomes? What can we get? A 1, a 2, a 3, a 4, a 5, and a 6. Okay, what do you think random means? There's no what? No bias. Good. Wow. Excellent. No bias. The next outcome of a random event is not known, but over repeated trials, the likelihood of specific outcomes could be predictable. Likelihood. Okay, so do you guys remember when we watched that video with the normal distribution with all the little pegs?
Yeah.
Okay, so each individual bounce of the balls was random, right? But over repeated trials, over repeated bounces, we could predict the likelihood of specific outcomes to a reasonably high degree. Does everybody understand what I'm saying? Okay, perfect. Okay, a fair game is one in which you expect to win as often as you lose. Now, just be careful when you spell lose because lose only has one O, as I spell it wrong. If you put two O's in it, it's loose, not lose. Okay, so who can think of a fair game? Okay, what about rolling a dice and you win if you get a 6? Is that fair?
No.
No, because you lose 5 times out of 6, right? And you only win for the 6. Okay, what? Rolling a dice and you win if you get evens. Okay, rolling dice and you win if even. That would be fair. Flipping a coin and you win if it's tails or heads. One or the other, not both. If you won for both, it would be not fair because you'd win all the time. You'd like that game, but it wouldn't be fair. Okay, can we flip? Okay. Okay, here we have a square dartboard. Dartboard. It kind of sounds like artboard. I don't even know what that is, but it amuses me. Okay, I'm going to pause it while I pass out rulers. Here we have a dart game at a carnival with the following rules. It's $2 that you have to pay for each dart. Then you get blindfolded and you have to throw the dart at a wooden board that is painted to look like this. Okay, it's supposed to be blue and yellow, but obviously you guys don't have blue and yellow. You've got gray. But you can tell which parts are the yellow parts, right? It's the lighter ones. Okay, we're going to assume that every dart throw, a trial, is random. Okay, so each trial, every throw is random. Is there an equal chance of hitting the hitting point on the target? Why or why not? You're blindfolded, so there's no skill. Okay, we'll discuss it. Talk about it with your people, and then we'll share things out with everybody. What did you guys decide? What, really? Okay, they're all equally likely because there's no skill, right? There's no bias because we're blindfolded. Okay? It's random. Okay? For some of us, we're not even very likely to hit the board. Okay, number 2. What is the probability of hitting is the probability of hitting a yellow region equal to the probability of hitting a blue region? Why or why not? Okay, can we prove it if we think they're equal, and can we prove it if we think that they're not equal? I gave you rulers. Can we agree that these are like little squares? But there's more of them. Okay, I gave you a ruler. Do you think you could like figure out how much of the area is yellow and how much of the area is blue? Okay, try it. You're in the Smart Kids class. You got to work. Work, 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 work. Okay, so if I wanted to find the total area that is blue, how could I do that? How do I find the area of a square? Length times width? Okay, so how long is this side and how long is this side? Eight what? I think I used the inches side and it came out pretty nice to like, I think it came out like, okay, so can you stop? Stop. Okay, so what did you get for inches? Okay. So we can brain exercise. Can you stop? Thank you. Okay, are we ready? Almost ready? Can you put that away? All right, but I was not. I was probably just recording myself eating chips earlier when I thought I was not recording. It's awesome. So they thought they were going to watch a math video and it was just me like stuffing Cheetos in my face. It's great. It's great. It's going to live on the internet forever, guys. It's going to be awesome. Okay, we'll get ready. What would be an easy number of trials to perform? Okay, let's make it a little bit bigger because remember that we get better accuracy. Let's think of multiples of 10, like maybe 100. Can we do 100?
I mean, sure.
Okay.
I know.
So we're gonna throw a dart 100 times. We're writing it here. We're gonna prove what we said, if it's favorable or not. Okay, how many times are we going to expect to win out of those 100? Okay, we're gonna win 25 times. I'm gonna say about 25 times. Okay, so if we win 25 times and we win $4 each time, how much could we win? Okay. We're winning $100, but how much did those 25 times cost us?
50.
How much?
50.
Okay.
Either that or I just said stupid.
No, okay, well we pay these are our 25 times where we win. Each time costs us $2, so how much did it cost to win 25 times? 50. Someone said 200, so I'm just like clearing it up. What? Okay. So it's 100 minus the 50 that it cost us to play. That's a 100. What?
It's like 25.
We're just talking about the wins right now. We're going to do the losses in a minute. Okay, so how much do we win? Okay, so we're up 50. All right, now let's do the losses. Okay, can we stop making the tapping noises, please? It's really distracting. All right, what do we have for losses? If we lose, we're going to lose about 75 times out of 100. Okay. How much money are we going to lose? Lose 150? Okay, so we're going to say that's minus 1. What? I did. We're going to lose 150 bucks. Because it's $2 for every 75 times. So what is our net? If we only make $50 from our wins and we lose 150 on our losses, how much are we going to lose overall? Yeah, we're going to lose $100 for every 100 throws. So is this favorable to the player? No. So we can all say not favorable. Okay. We're going to talk about two different types of probability here. Theoretical probability is calculated based on reasoning about an event, but we don't actually perform any trials. Experimental probability is calculated from the results of an experiment. Okay, the more trials we do, the more our experimental probability should approach the theoretical probability. Does that make sense to everybody? Okay. When you think about what we did with our flipping coins, like how many heads did we get? Some of you got some really weird, like a lot of heads or like not that many heads compared to everybody else, right? But the net effect over everybody was that we kind of got what we expected, right? All right. Let's say that we pick a card from a standard deck of 52 playing cards. We're going to find the probability of picking an 8. So there's an 8 of hearts, there's an 8 of diamonds, there's an 8 of spades, which is an upside down heart with a little dingleberry. Okay, and then there's an 8 of clubs, which also kind of has a little dingleberry. So we've got 4 8s out of how many cards? 52. So can we please write that as a decimal? I don't have my answers. You guys are going to have to do it on the calculators. Okay, so 0.07. Can you give me 3 decimal places, please?
0.76.
What's the one after the 6?
9.
Okay, so 0.77. Let's practice good rounding. Okay, we're not going to truncate in here. All right, notice that it's not exactly that, so I did this little symbol for approximately. Okay, if I'd have had like 1 out of 4, I could say that that was exactly 0.25, right? But if I had to round, I say approximately, and I do the little like stacked tilde equals, the squiggle equals. Does that make sense to everybody? Okay, perfect. All right, picking a red card. Okay, how many red cards are there? Half of 52. So what is that? 26? 26 red out of total 52.
No, 50.
So 50%, but we're going to write it as a decimal. 0.5.
Wouldn't you have to take the 2 together about? Out of 50. Never mind. I'm just saying.
That was a good question. I'm glad you asked.
Thanks, I'm glad I asked.
Okay, you ready to flip? Here we go. All right, you guys are going to love this. And by love, I mean someone might start crying or swearing. Okay, we're rolling 2 number cubes. Cube A is a standard 6-sided dice. Cube B has 4 faces labeled with 2. Stop. Do I need to take that? Okay, great, thank you. Good idea. And 2 faces labeled with an 8. Okay, we are going to list all the possible outcomes for rolling both number cubes. Guys, when we list all the possible outcomes like this, that's the sample space. Okay, so we're going to write out the entire sample space. And we're going to do this organized like. So we're going to put them in a specific order. We're going to list them cube A first, and then cube B second. Okay, we're going to do it systematically. That way we can not go crazy. All right, you guys ready? All right, so what are all the possible outcomes for cube A? 1, 2, 3, 4, 5, and 6. Okay. Now, isn't that going to be the same no matter what I get for what? Like, I could have a 1 with, what are my possibilities for cube B? I have 4 faces labeled with a 2. So that would be 1, 2, 3, 4 could be a 2, and then 2 faces labeled with an 8. 8, 8. Okay, now regardless of what player B is rolling, what should player A be rolling for all of these? A 1. So I'm just going to do a 1, a 1, a 1, and a 1, and a 1. Okay, read the directions. What are the 2 possibilities for the dice that player B is rolling? Cube B has 4 faces labeled with a 2 and 2 faces labeled with an 8. Okay, now given this example, do you see that this whole column right here is going to have a 2 for player A? Okay, and then what are the outcomes for player going to be going to be? B going to be? Same thing as they were in this column. It'll be 2, 2, 2, 2, 8, and 8. Okay, now I want you to do the rest. Okay, great. We're going to keep going. Okay, looking at our total number of outcomes, how many possible outcomes do we have? 36. So if we're going to find probability, it's desired outcomes over total outcomes. So the probability of rolling a 4 on cube A and a 2 on cube B. So we'll have desired outcomes over total outcomes. So how many of our, out of our sample space, how many times do we get a 4 and a 2? Do you guys see them right here? Yeah. Okay, so our desired outcomes are 4, and how many total outcomes again? 36, and that reduces to, I wrote 39, I meant 36. That reduces to 1 over 9. Can we write that as a decimal, please? And it's not going to be exact, so give me the little squiggle. Equals. What is it? 0.111. I did approximately, so I'm rounding. Okay, next. We're finding the probability of rolling a 2 on both number cubes. So 1, 2, 1, 2, 1. Okay, I got 4 again. Okay. So let's practice this notation. The probability of 2 and a 2 is going to be also 4 out of 36, which we already know is 0.111, about. Okay, Mike is rolling cube A and Joseph rolls cube B. Assume that whoever rolls the higher number wins. Describe the set of outcomes in which Joseph wins. So which one is Joseph rolling? What? Cube B. Okay, so look at what happens for Joseph to win. I think there might be 2 ways. Okay, so here's one way. What do all of these have in common? Okay, so write this down. The first way that Joseph can win is by getting an 8, because no matter what Mike rolls, 8 is higher. Okay, write it down. What is the other way that Joseph can win? Correct. So the other times when Joseph wins are these four. So Joseph can win if he rolls a 2 and Mike rolls a 1. Is this making sense to everybody?
Yeah.
Okay, perfect. Okay, what's the next question? Suppose that, what does it say? Suppose
That life and death will the same God from above multiple times with the same rules, determining the probability that Joseph.
Okay, so this is asking about like our experimental probability, like approaching our theoretical probability, right? So in theory, what are the chances that Joseph will win? Well, let's section it off into chunks.
16 times.
Okay, 16 out of how many? Out of 36. Okay, are there any possible ties?
Yeah.
Okay, how many ties are there? 4. Well, no, that's not a win for him. Okay, so we're just talking about the options. So 16 out of 36, Joseph wins. 4 out of 36, tie. What about for Mike? It's basically like all of these, right? Don't pack up yet. 16 also out of 36. So write each of those as decimals. And like answer the question. Okay, that's it. You can pack up.